Let's go over example 3. Now in example 3, we have these two rational functions. So every time I have rational function, the way I find the domain is by taking the denominator and set it not equal to 0. So for x, we got x cannot be equal to -5. So the domain is all real numbers except x cannot be equal to -5. So on the number line, if I were to sketch that from -infinity to +infinity, we got -5 here, and we are excluding it, so we put an open circle going from left to right. We are going from -infinity up to -5, but not including it. So this open interval from -infinity, comma, -5. And jumping to this part, we include the union sign, and we are going from still excluding -5 all the way to +infinity. And same manner can be used for finding the domain of this. So take the x and set it not equal to 0. So we know the domain of this is all real numbers except x cannot be equal to 0. So same thing on interval, for interval notation, when there's 0 here, going from left to right. We go going from -infinity up to 0, but not including it. So open interval from -infinity, comma, 0. Jumping to the next part, we put a union sign. And going from 0 all the way to +infinity. So these are the interval notation of these two domains. So let's find the sum of this. So f plus g is equals to x over x plus 5 plus 1 over x. Well, we have two fractions here, so I recognize right away that the lowest common denominators for both of these denominators is the product of both denominators. So take this, multiply by x, and doing the same thing for the numerator, and take this, multiply by x plus 5, and multiply the numerator by the same x plus 5. We are going to get, let's see, I'm going to put both of these common denominators as 1, like that. And then x times x is x squared, distributing the positive 1 into the x plus 5. We are going to have plus x plus 5. And I don't think we can factor this out, so we are good on this. Now take a look. The results right here says that the domain of f plus g, domain f plus g, we take the denominator and we set it not equal to 0. And then we know for sure that x cannot be equal to 0. X plus 5 cannot be equal to 0, so x cannot be equal to -5. So the sum has a denominator of all real numbers. Except x cannot be equal to 0, comma, -5. Now what about the interval notation for this? Well, let's sketch a number line again. -infinity to +infinity. So we have -5 here, we have 0 here, going from left to right, excluding -5, 0. We are going from -infinity all the way up to -5, but not including it. So it's an open interval, -infinity, comma, -5. Jumping to the next part, we are supposed to put a union sign, and then still excluding -5, going all the way up to 0, but not including 0. So it's another open interval, -5, comma, 0. Jumping to the next part is another union sign, still excluding 0, going from here all the way to +infinity. So, and of course, if we take a look at this step here, we can tell right away that x cannot be equal to -5 and x cannot be equal to 0. So you see some restriction anyway. So yeah, this is the interval notation for the sum of the two functions. Now let's find the difference. So f minus g is going to tell me to do x over x plus 5, yeah. minus, what is it, 4 over x. And I'm not going to put 4 over x inside the parentheses because it's pretty obvious, you know. If I were to put in the parentheses, it's still going to be a -1 times this, so it's going to be a negative fraction anyway. And same thing, same common denominator as earlier. So the lowest common denominator is still going to be the product of both of these denominator. So this is x plus 5 times x plus 5, and this is times x. So that means we are going to have x times x plus 5. Let's see, it's x times x squared, and then minus 4x, and then minus 20. That's how we do this, because we are distributing a -4 into the x plus 5, so that's how we get that. And guess what? At this step, at the result, the domain of f minus g can be found by taking the denominator and set it not equal to 0. But if we do this, we're still going to get the same restriction as we did earlier for the sum. So x cannot be equal to 0 and -5. And the same interval notation from -infinity to -5 union, -5 to 0 union, from 0 to positive infinity. Like that. And of course, this step right here, it also had a same restriction of x not being able to be -5 and x not being 0. Now last one, let's find the product. What we have to do, we write f times g, which is going to be x over x plus 5 times 4 over x. But hey, this is straightforward. Numerators multiply together, denominators multiply together. So we got 4x in the numerator. And we got, let's see, distributing the x in here, we got x squared plus 5x. But x squared plus 5x, it just, you know, it's just the same as this. So the restriction, the domain of f times g is still going to be taking this denominator, x times x plus 5. Well, I could take this, you know, but I have to like factor the x out. So, and of course, this is just equivalent to this. So that's why I'm taking this instead. We're still going to get the same restriction. X cannot be equal to 0 and x cannot be equal to -5. So the domain of f times g is going to be all real numbers except x cannot be equal to -5 and 0. So on the number line going from left to right again, we are going from -infinity up to -5, but not including it. Jumping to the next part, the union sign, going from -5 up to 0, but not including it. So another open interval. Union sign to go to the next part, going from 0, not including 0, all the way to positive infinity. So another open interval. Like that. So all real numbers except for x not being -5 and 0. And yeah, that is how we find the domain of the sum, difference, and product of these two functions. Well, let's sketch the number line from -infinity to positive infinity, like that. And let's say we have the point excluding -5 and excluding 0 right here. So the domain of the function f is all real numbers except x cannot be equal to -5. And the domain of the function g is going to be, oops, forgot to mention, let's write this. This is the domain of f, d sub f. And the domain of the function g is all real numbers except that x cannot be equal to 0. One circle right there. This is the domain of G. The domain of the sum is going to be all of the x values in common of the domains of f and g, and also all of the restriction included. So really we have to include this restriction and this restriction. And then we have to include all of the x values that they have in common. So basically it's just this whole part, and then put this restriction down here, and then this whole part, put this restriction down here, and then this whole part. So that's how we know, that's how we graph on a number line the domain of the sum. And we do the same thing for the domain of the difference. And we do the same thing for the domain of the product.